So here's my next research video. Hydrogen abstraction, Higgs boson particle masses, supersymmetry LHC 5G well SETI. Okay, so this was done on August the 20th, 2012. Today is September the 8th. I'm working on notes at 9:24 p.m. My thoughts. I guess I started it at 3:30 a.m. and then went back over the notes on another day or later, whatever. Google search was for the keyword hydrogen abstraction. The data for the Higgs boson particle masses, supersymmetry LHC, and PDF results also came up during this search. So the data quotes: probing minimal supersymmetry at the LHC with the Higgs boson masses. IOP select from these scientists and doctors. It was from April 2012, July 2012, so this is very recent. Abstract: the ATLAS and CMS collaborations report indications of a Higgs boson at MH 125 GeV. In addition, CMS data show a tenuous bump in the ZZ channel at about 320 GeV. We make the bold assumption that it might be the indication of a secondary line corresponding to the heaviest scalar Higgs boson of minimal supersymmetry H, and discuss the viability of this hypothesis. We discuss also the case of a heavier H. The relevance of the BB decay channel is underlined. August 20th, my thoughts. The keywords from the data notes is 125 GeV mass of Higgs boson MH. Formula keywords from the ATLAS CMS reactions data. ATLAS plus CMS plus collaborations plus reactions plus P plus P to H plus ALL to YY plus ALL, P plus P to H plus ALL to ZZ plus ALL, ZZ to 4 charged leptons. My thoughts continued August 20th. Cross-reference on Google with well SETI data, video data. The keyword is 4 charged leptons. Neutrinos mimic leptons. Mix them together from the ATLAS CMS results. Question for me: what is ALL and YY? I'm going to Google to find out. I also found that line 18A, 3W2, neutrino split decay, muon, quarks, mesons, 5G, UFO formula is well SETI on this video here. The keywords with the video on the Ideal Says You channel are. So let's just take a look at this real quick. And I'll just show it to you. It's on the Idea Girl Says YouTube channel.
Okay, this is part 135.
So it's part 135.
W2. Neutrino split decay muon quarks.
And it's got different calculations with it. If you go into the info section, some of the videos I give some of the notes, and other ones you have to go into the Victoria Stafford Psychic Investigation website. That's where I've been putting the data because that's where I can fit it for now. I'm probably going to start a new website soon. I was just trying to use this one up. That's what it says: paranormal, UFO, aliens, well, severe storm predictions. There's a lot of stuff at the beginning here and then down here. I haven't been putting the Higgs stuff. I've been doing severe hurricane predictions right now. But the Higgs signal is on here as well. And I've got it tagged. I don't know if it shows. There's the categories. If you go in the categories, you click on the Higgs boson well alien formulas, it brings up all the posts for it, okay? So that's an easy way to find them, just so you know. So we'll go back to this here. So the keywords with the video on the Ideal Girl Says YouTube channel are: my thoughts continued from February 17th, 2012, 12:24 p.m. So I'm backtracking to February 17th when I originally started working on this particular video right here. So we need a charged current interaction. So can the turbine invention, which comes up in the well data, send a laser beam to the neutrinos to charge them into the equivalent charged leptons? Inverse beta decay, VE plus P to N plus E plus. Neutrino electron scattering, V plus E to V plus E. Or because it breaks up, 2H to plus V to P plus N plus V, since atoms split and join other particles. Using a moderator with the neutrino electron scattering, can you slow it down so it doesn't break up, but instead splits in half and doubles the power? Let's see if anyone split a neutrino. The Neutrino spectral split in a core collapse supernova, a magnetic resonance phenomenon. So I googled that word and this is what came up. So Sebastian Gales and Christina Volop submitted on March the 28th, 2011. That came up. Okay. So February 17, 2012, my thoughts. The keyword here is Y and beam. Upsilon Mesons, 4 quarks. I said the neutrinos divided up into 4 quarks, and you couldn't see them during your testing. I would look to see if these Y5S particles are the same as neutrinos. And maybe they've given them a different name in Japan than in North America. My thoughts. February 17, 2012. Based on the results of this experiment, what if the neutrinos split and divided into 2 smaller particles, or even 4, so that they could not be detected because our particle reactors cannot detect something that's small? So I go to a quote. So when a quark emits a W plus boson, it can turn into other quarks, then just the down quark. Electric charge has to be conserved, so the other possible quarks besides the down with charge -1 to 3 are the strange and bottom. Now over the long term, since the strange and bottom quarks weigh more than the up quark, the interaction will end up with just the down quark. The strange and bottom quarks will convert to a down quark or be reabsorbed or do something cool. But on a short enough time scale, any of the down quarks, DSB, can end up created along with the W+. Like anything in quantum mechanics, there are different probabilities of these things happening. And like anything in quantum mechanics, there are different phases which can cause interference. Our sum total knowledge of what happens in this interaction is held in the Kobayashi-Masakawa or CKM matrix. The entries of the matrix specify an up-type quark, UCT, and a down-type quark, DSB. It has a 3 times 3 equals 9 entries running from UD to TB. Each entry, XY, defines the amplitude that when the W plus emitted by an X quark with charge plus 2/3, the resulting quark with charge minus 1/3 will be the Y quark. February 17, 2012, 5:50 p.m. was when I was doing those notes. My thoughts. You can take the formulas I've provided and see if you can split the neutrinos into 4 quarks, which seems to be the case in your experiments. Thus, we technically have 4 times the power of 1 neutrino if this is the case. What kind of velocity do you think that could create? 4 times the speed of light. 4 times the speed of light equals 1,199,169,832 m per s. Now take this equation and figure out what, with your mathematical functions, how fast you would arrive at Mars with this type of UFO engine speed. I have no idea how to do that. Do you? Let us know. Quote, this means that when Earth and Mars are closest to each other, the distance would be 1.5 to 1.0 equals 0.5 times the average distance of Earth from the Sun. When Earth and Mars are on opposite sides of the Sun, the distance between would be almost 1.5 plus 1.0 equals 2.5 times the average distance of the Earth from the Sun. Astronomers and later space exploration scientists have been working at measuring the average Earth-to-Sun distance, called the astronomical unit, for several hundred years, and arrived at a value of about 149,598,000 kilometers since a spacecraft crashed into Mars because someone didn't use units of measures like meters, kilograms, etc. So these are the calculations I have. I'm not going to read out all the numbers, but that's the numbers I've got here. I was trying to calculate how long it would take to get to Mars because I don't know how to do it, and I was trying to figure it out. But these are my calculations. So less than 2 months to get there if we are able to create this thing. I said 3 days. I guess I was off quite a bit. So there's the other calculation. So you would have to split the neutrinos 5 times in order to make it 20 times altogether. So the keywords are molecule, resonance circuits, leptons, turbocharger, laser beam, inverse beta decay, atoms and particles. Neutrino spectral split in core collapse supernovae, a magnetic resonance phenomena from Sebastian Gales, Christina Volop, and this is just here's the other PDFs that came up with that particular file. Basically what I'm doing is going over the WOW data that came up in February that has to do with what we're talking about. Analytic bounds on all lights, Higgs boson masses from supergravity, from Prober Roy, Tata Institute from Bombay, India. Received in September 1985. Was published 1986. Testable analytic bounds are derived on the physical masses of all 5 Higgs particles of the softly broken supersymmetric SU3, SU2, and U1 theory with a minimal low energy particle content. These follow in the framework in which the soft terms as well as radioactive electroweak symmetry breaking arise from some underlying n equals 1 local supersymmetric grand unified theory. He wrote that in 1986. August 20th, 2012, my thoughts. The keywords SU3 look like the math equations found in Barry's axial force 5 bosons theory. I'm not going to blog this portion, I'm going to keep it for my own records, but I'll just show it to you, okay? There's quite a bit of stuff here. So this is Barry's notes where he's talking about the indications of a Higgs boson around a mass have been presented by ATLAS and CMS. There's the calculations for the 4 charged leptons. There's the value of the mass, and I'm not sure what this is. Basically, these are just the notes about it, and I'm not going to blog them. You'd have to go to the link to look at them. But I don't want to read all this because it's very, very long. So these are all the calculations that they did to get to this Higgs boson signal. And here's a graph. Solutions of equation versus tan B for the values of MH considered in the text. And there's another one. Figure values of the axial meson mass versus tan B for the values of MH considered in the text. Export PowerPoint slide. Couplings of H and H channels WW. WW equals ZZ. See, these are all the little calculations CMS and ATLAS did. There's their drawings. The Feynman diagrams contributing at particle level to the process of P plus P to H plus 2 dots. The reason I get this information is so that I can try to understand what's happening. Talks about full triangles, the Gluon Higgs effect vertex induced by the loop top. Tables, cross sections. These are the results. And let's go down here. Another graph here. So there's the CMS results and flavor, GG. So I'm still not quite sure what this graph means, but I figure if I keep the data, I'll figure it out sooner or later what it's talking about. And again, when I look for keywords, I look for stuff that are in the same data. And this is just showing all the different results that they had with these from CERN for the Higgs boson. And we're at the end there. So it's on iopscience.iop.org, and there's the link there, okay? So you can take a look at that article. It all talks about the decays and everything, okay? So that's the end of that video. We're going to go on to the next one. Thank you for watching.